I'm Anil Kumar. In this video, we'll discuss organized counting with Venn diagrams and we'll elaborate on the principle of inclusion and exclusion. The question here is, in a group of 20 players from hockey and basketball teams, 14 players are on the hockey team and 18 are in the basketball team. Based on this information, we have 4 questions. Part 1. Use Venn diagram to illustrate the situation. B is determine the number of players in each region. C is explain why. You cannot use additive counting principles to find the total number of players on the teams. And D is illustrate the principle of inclusion and exclusion with this example. Let's do the Venn diagram. That means we have a set, the universal set. In this universal set, what do we have? We have 20 players, right? So let's call this universal set as S. And these 20 players are belonging to either hockey team or basketball team. So we have 2 circles illustrating hockey and basketball teams. So let us say this one is for hockey, that is for basketball. Now, how do we find the number which is common to both? Now, it says in a group of 20 players, so total is 20 players from the hockey team and the basketball team. 14 players are on the hockey team and 18 are in the basketball team, right? So that means there are some common players also. So if you add 14 and 18, you are adding these common players twice, correct? And therefore, you have to take away to get the exact number. And that is what principle of inclusion and exclusion is. So we'll start from part D, right? So what we have here is 20 is total number of players, right? So total number of players is equals to number of players playing hockey plus number of players playing basketball, take away number of players which are common to both, right? So intersection of hockey and basketball. So that is what it is. And this is principle of inclusion and exclusion. You understand, since these players are common, they are counted twice and therefore we have to take them out. We are given 20 players in all, so it is total is 20. Number of players in hockey is 14 plus 18 minus the number which is common, right? So we get the number which is common as equals to 14 plus 18, take away 20, right? So 14 plus 18 is 32. 32 take away 20 is 12. So we have 12 players which are common, right? So that is how we can actually answer this question. So in the Venn diagram, what really happens here is that 12 are here. So 12 are common. Now, total hockey players are 14. That means 12 and 2 makes it 14. 18 is for basketball, so 12 and 6. So that is the situation, correct? So we have done part B also, which says determine the number of players in each region. So it is kind of like, these are 3 regions. This is only hockey, this is only basketball, and this is common to both. Explain why you cannot use additive counting principle. We cannot use additive counting principle to find the total number of players since the players which are common are counted twice. So the reason is that the common players are counted twice. So that is the reason, right? Why we cannot use counting principle. So we have to take them away. And that is the principle of inclusion and exclusion. So since these are included twice, we have to exclude them. And that is the principle of inclusion and exclusion. So with this example, I hope you understand or get an idea about what this principle is and how we can apply it to understand the situations. I'm Anil Kumar. You can share and subscribe my videos. Thank you and all the best.